Hi, this is Mr. Mabrey, and we are going to do some drawing atoms notes. So get out your own line paper, and here we go. Title your paper, please, Drawing Atoms Notes, with your name, the date you take your notes on, and the period you have me for class. And let's start off with writing out what I like to call our driving question for today. So our driving question is, if all 118 elements are made of atoms, how is one atom different from another? Pretty great question if you ask me. We've got tons of different elements. How are they all supposed to be different? Well, let's take a real popular one. Let's take carbon. So on our sheet, let's write down, we got a carbon example. And if we look on the periodic table, you know now from reading your textbook that you can look at the atomic number and the atomic mass to figure out how many protons, neutrons, and electrons carbon has. So for instance, I'm going to hold my periodic table up to you guys as soon as I grab it. So here's our periodic table. We're looking for carbon. And there we see the carbon's atomic number is 6 and its atomic mass is 12. So what that tells me is I'm going to have 6 protons in my nucleus. So let me grab some protons. Protons are really nicely drawn with circles. Circles that are filled in. So there I got 1, 2, 3, 4, 5, 6. I've got 6 circles. My 6 circles are sort of hanging out together, and now I'm going to get some more circles. Except, you know what's weird about my circles? My circles have got this weird white background on them. You guys don't have to put white background on your circles, but go Microsoft Word. That's what it's doing for me. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 protons all hanging out in the middle. And just to have a little bit of a key, that seems wise. Let me put this over here. I'll make myself a little key. You should make a key along with me. Da, 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 da. So we'll have this color be our neutrons. Remember, they are neutrally charged. And then we'll have this color be our protons. Protons are positive. Protons, you are positive. And then electrons are tricky. It really is going to depend on the teacher, you guys, on how they want you to draw electrons. Because as you read in your text, you know the electrons are just spinning. They're just spinning around the atoms. We never quite know exactly where they are. So some people like to draw them in these set orbits around. Some of them like to draw them sort of in a cloud. So I'm going to say, why don't we go ahead and do the orbit thing? And let's take and make another circle, but we want to make this a small circle because you'll remember from reading from your textbook, come on, small circle, that these electrons are 200 times smaller. There we go. Let's fill that. Let's go maybe some yellow. There it is. That did not work out good. Fill. Let's do a nice green. There it is. You can do any color you want, you guys. But I'm going to try to make this as small as possible because it's 200 times smaller than protons and neutrons. So mine are going to be over here. And they're just, whoa, that is a fat electron. They're just hanging out outside this atom. You can see I'm going to give it a lot of space. There we go, get some over here. Now you're going to, when you get into high school, we're going to put these electrons in specific spots, but for now we're just going to sort of shove them out there. 1, 2, 3, 4, 5, 6. And they're just hanging. Oh, fat electron again. Here we go, move with me. Great. And that is how you draw atoms. Pretty easy. Electrons on the outside, floating around, going crazy. Protons and neutrons in the middle is the nucleus. Remember, when you look at the atomic mass of an atom, that's how you know how many particles are in that nucleus. And when you look at the atomic number, it tells you how many protons go in the atom. And that answers our driving question. How are they different from one another? Well, it's those protons, the little blue balls that I drew right here, the 1, 2, 3, 4, 5, 6 blue balls. That's what tells me that this is a carbon atom. So I hope this makes sense. I'm going to have us write a few more things down here. So once you draw a carbon with me, can you write, let's write down 4 statements. Here we go. Statement 1. The number of protons determines what kind of atom you have. This is called the atomic number. 2. The number of electrons determines the charge of the atom. And we are going to underline charge. Electrons equal protons. This would be a neutral atom. If electrons are greater than protons, that's right, negative atom. And if electrons are less than the protons, that's right, it is a positive atom. So for instance, up here on our drawing, if you look, we drew 6 positive protons and we have 6 negative electrons. So we drew a neutral atom. But if I came up here and I got rid of this guy, I just got rid of a negative. So he's less than protons, so that would have made him positive. Or, he's back. What if I added one of these? And boom. See, I just added one right here? Well, we just made a more negative atom. Isn't that cool? I bet you guys didn't know you could do that. All right, let's go to the next statement. The atom's mass is determined by how many protons and neutrons, because the electron essentially weighs nothing because it's 200 times smaller. So that's why if you can draw an atom, just count what's in its nucleus, that's its mass. And our last statement, the number of neutrons determines which isotope the atom is and provides stability. Oh, didn't see our last phrase. There it is, provide some stability. So neutrons are good. Neutrons keep things stable. Now if I, for instance, to help you out with these isotopes, so see my neutrons over here, they're these guys. If I get rid of him, is that still carbon? Yes, it is, because I didn't change the number of protons. I still have 1, 2, 3, 4, 5, 6. But now it's a different isotope of carbon. Let's bring it back. Oh, there he is. Still carbon. What if you got a friend? Boom. Another neutron. Still carbon? That's right. It's just another isotope. But the most common form of carbon is what you see here. 6 protons and 6 neutrons. Okay guys, so that's all there is to building atoms. Make sure you know how to draw an atom. Make sure you know what atomic number and atomic mass is. And make sure you know where all those electrons and protons and neutrons are. If you get stuck, you got your textbook. You've got things you can search for on the web. Let's practice drawing and making some atoms. Here we go.